Two uniformly charged insulating solid sphere A and B, both of radius A, carry the total charge. This total charge minus Q. This is plus Q total charge. B sphere is minus Q total charge. The sphere are placed touching each other. These are now touching each other as shown in the figure. If the potential at the center of the sphere A is VA and then that the center of the B is VB, then the difference VA minus VB is what they are asking. Before calculating potential, we want to find the electric field due to the single sphere. So electric field outside the solid sphere, already we know the relation 1 by 4 pi epsilon q by r square if r greater than A, greater than radius of the sphere. Electric field inside the at a radius r, if r is much less than A, the electric field distance from the center of the sphere r is less than the radius of the sphere, that electric field is, this is out E out, this is E is equal to 1 by 4 pi epsilon q r divided by A cube. This is r is less than E. So now we want to calculate potential due to the sphere not EA. Just we can calculate first general potential. Potential due to the sphere of charge plus q from infinity. So if charge is sphere having plus q charge from infinity, that potential, don't call it, this is A, minus infinity to 0 minus of E of dr. Now substitute, we can break the integration to minus plus infinity to the sphere radius A, then another limit will goes to A to 0 because in these two places electric fields are different. That's why I mentioned here electric field at r greater than radius A. This is if r is the electric field inside the sphere is less than A, radius of the sphere, this is. So we are breaking this integration into two, plus infinity to A and then A to 0. We are substituting the corresponding electric field here. Now the first integration is straightforward. So q by 4 pi epsilon naught minus is already there. Then if you are integrating, it will can become minus of 1 by r, minus into minus plus 1 by r plus infinity to A minus cube by 4 pi epsilon A cube is constant because it's the radius of the sphere. You can take all the quantity out. Q is a charge. R into dr is r square by 2. Now the integration limit A to 0. Substitute the upper limit, it is 1 by A. If you are substituting lower limit, it goes to 0 because 1 by infinity goes to 0. The final option, the first integration is q by 4 pi epsilon 1 by A. The second one, q by 4 pi epsilon A cube. If you are substituting lower limit, upper limit, it goes to 0 because 0, the lower limit A square by 2 minus of. So minus into minus plus q by 4 pi epsilon A, the first. The second integration, A square, here A square will get cancelled, so q by 8 epsilon A. If you are summing these two, you will get 3q by 8 pi epsilon A. This is potential due to the charged sphere if the charge is plus q. Now come to our real picture. Here actually there are two spheres touching each other. The potential due to the charge sphere A by its own charge plus q, we can write 3q by 8 pi epsilon A. Now the minus q is touching. Here there are two spheres. This is A, this is B. The center, at the center, the potential due to the plus q charge in the sphere A, 3q by 8 epsilon A. Because of the minus q charge is having the sphere B touching with each other, the separation is 2A. So potential due to this charge at the center q, at center of the sphere A is, because minus charge, so minus q divided by 4 pi epsilon, the distance 2E. If you are simplify these two, you will get q by 4 pi epsilon A, that potential VE. Similarly, the net potential at the center of the charged sphere B is by its own charge at the center minus 3q divided by 8 epsilon A due to the sphere A having positive charge plus q. The separation between these two is 2a. At the center of the sphere, due to this charge, a charge is q by 4 pi epsilon naught, the distance 2a. If you are summing these two, one is plus, another one is minus q by 4 pi epsilon dA. Now we have to take the difference. This is AC. VA minus VB. VA we know. VB we know. If you are subtracting these two, then denominator is same. Numerator q minus of minus plus q 2q divided by 4 pi epsilon dA. So 1 to are 2, 2 to are 4, q by 2 pi epsilon A. So this is the answer. The option in the question paper is 3.